This is a 2017 AP Calculus Practice Exam Free Response Question number 1, C and D section. C. Find the position of a particle at t equal to 4. Is particle moving toward the origin or away from the origin at t equal to 4? So it's given the function velocity vt equal to t to the 6 minus 13 times t to the 4 plus 12 over 10t times t to the third power plus 3, and also says that at time t equal to 0, the initial position of the particle is x equal to 7. So we need to find out where's the position particle first. So we use xt as a function for position at t equal to 4 is x to 4. We need to know where is the position at. So, and then also the second thing we need to find is velocity at 4. See if it's positive, it's greater than 0, and then the particle, if it's velocity at t equal to 4, and then greater than 0, and then the particle will move to the right. If it's velocity at t equal to 4, less than 0, and then it will move toward to left. Okay, so find the x position function at t equal to 4. So we have a condition x, when x equal to 0, x is equal to 7. So 7 plus the integration of a 0 to 4 dt. Remember, when we have a position function, if we take derivative of a position function, we got velocity function. If we want to reverse, we have the velocity function, then we need to take integration of the velocity, and it's equal to position function. So position function is equal to the initial value plus the integration of the function from 0 to 4. So this part we can use finding the integration from 0 to 4 dt, use calculator. First of all, we just plug in our function to the y1, x to the 6 minus 13 x to the 4 plus 12 divided by 10 times x to the third plus 3. And then we take integration of that, this function here. We do math 9. The lower limit is 0. The higher limit is 4. And then we do alpha trace. And then function from y1 and dx. Enter. It's a negative 0.288. So we have minus 0.288. And then 7 minus 0.288. It's 6.712. So we see the position is in the positive sign. This is the origin here, and then position at t equal to 4 is 6.712. It's on the positive side here, somewhere around here. And then if its position at the t is 4 is negative, will be on this side here. All right. And then now we need to find v4 is greater than 0 or less than 0. If it's greater than 0, it's toward to the right and moved into the right. If it's less than 0, it's moving to the left. So v4 at 4, you just plug in 4 here, 4 here, 4 here. So it'll be 4 to the 6 minus 13 times 4 to the 4 plus 12 over 10 times 4 to the third plus 3. And then use your calculator, and then you will find out what is the value of that. Let me see. Is 1.213. Is also greater than 0. Greater than 0, so it's toward to the right. So this particle would move into the right. If it's moving to the right, is moving, the particles moving away from the origin. If the particle moved to the positive, greater than 0, and then the particle moving to the right, going this way, so it's away from the origin. So you need to write a sentence: the particle at t equal to 4 is moving. So just like writing the sentence from here is a particle moving toward, away, toward or away. It's away, right? From the origin. Because x, the position at 4 is greater than 0, and velocity at 4 is also greater than 0. In this question, there will be 4 points. Let me see how many points. 4 points. If you have an integration over this part, you got 1 point. And then you use the initial condition, you're adding 7. And then you find position is toward to the, oh no, it's moving away from the origin. Then you writing this sentence, and you got another point. So its total is 4 points. All right, now let's do the part D. Let's read the question first. D. During the time interval from 0 to 4, T, from 0 to 4, does the particle return to its initial position? Give the reason for your answer. All right, so they want a 0 to 4. So we know the initial value at the position at initial value is 7. That's given from the questions. And then we can find also position at the 4, what will be. But we need to find somewhere around here, see if it's returned to the 7 or not. So we can pick x to the of the 1. If t equal to 1, what happened, you know? So, but before we're doing this, we need to state, is this function here, x1, xt is continuous or not? Why is it continuous? Because we know vt is continuous, right? So vt, x position function is continuous. Because on the interval from 0 to 4, because the vt is equal to derivative of x t. If you can take derivative of that, then the vt is also continuous. Then x position t is continuous. All right, so let's find x4. X4 is, we found it on from the section C is 6.711. So let's look for the x1. X1 is 7 plus initial is 7, and then from and plus 0 to 4 VT dt. So it's equal to, let's find this part here. Again, we have function ready. Then we have integration is 9 from the 0. No, this is for 1 to 1. Sorry, this is a 1 there, right? We want to find 1. After the limit is 1, and then go alpha trace, and it's 1 y1 and dx. We got 2.4. So 7 plus 2.43. 7 plus 2.403 is 9.403. So let's draw the graph about the persistent function here. From the 0 we have 7, and then 1 we have 9.4. Okay, this is 1 here. 2, 3, 4. 4 we already know is 6. So from here, the function is continuous. It must go like up here and go somewhere and then go here, like that. We don't know what happened here, right? We didn't find actual value here. But you know your function from the highest point got to go and down. There must be somewhere here you have it returned to the 7, right? Must be. So we will write a statement from t equal to 1 to t equal to 4. The particle moves from x equal to 9.403 to x equal to 6.711. So by the intermediate value theorem, the particle mass, you say, does the particle return, mass return to x equal to 7 during the time interval 0 to 4. This question is 2 points questions. You find a value between the 0 to 1 is 0 to 4 is 1, and then that give you 1 point, and you statement this intermediate value of the theorem, you got another point. All right, so that's all.